Welcome guys! There's so many little things that can go wrong with a snowblower, and many of the fixes are very simple. So if you understand how each individual system works, you're more likely to be able to fix it yourself and to be able to fix it faster than taking it to a mechanic. So let's jump right in and look at these individual systems.
Okay, now as far as the auger engagement goes, that's this lever here. Just pivots here. It does have a tensioner here, so you can tighten it or loosen it if you need more slack in the cable or you need to put more tension on the cable. It comes down here. This has a little quick disconnect here that you can disconnect if you need to. Down here to this little pulley, and whether that pulley turns or not, it doesn't turn very easy, but the cable can slide through there at least easily. The cable comes around another pulley. So these are all things to look at. You know, if all of a sudden your auger's not engaging, these are all just little things to check. Now, this cable goes up right up there and has a spring attached to that side. And that spring sort of helps dampen your engagement when you squeeze it. And it also helps to keep some constant tension on it, okay? Coming around the top now, just to look from the top, here comes the cable in from this side, right down there. And that cable comes up and is attached to the back of this spring right here. And the spring, of course, is attached to one side of this pulley. To balance the pulley, what pulls it backwards, what allows it to release is this spring right here. This pulls it away. And of course, when you squeeze the lever, let's just squeeze the lever here like that, okay? So I've let it go now, and I'm going to squeeze the lever here now, and let's watch that spring and what it does. So the cable pulls on that spring, and that spring gives it a little bit of a dampening. Okay, it's also stretching this spring, and that's the resistance you're kind of holding against when you hold the lever down up on the handlebar, is that spring right there. Okay, so it's engaging the belt here, and probably a little hard to see, but that's what engages the belt and drives this belt. This belt is also attached to a big pulley down here, and this large pulley down here. Let's look at it from the bottom so we can see it better. Here we are under the machine, and this of course is the drive, the big pulley for the drive, and you'll recognize the friction wheel here. And then of course this is the front of the machine here. Here's the snowblower part itself, the auger itself. And so this front pulley here is what the V-belt runs around. And you can see it's nice and loose right now because there's no tension on it. But of course the middle of this pulley is attached to a shaft, and that shaft is what runs your auger. Okay, so I was wrong about this. Let me just correct myself here. When I squeezed the lever here to engage the drive, okay, it was moving this pulley down here, which was moving this, and I thought for some reason this pulley worked like this pulley. In other words, this one, when you squeeze the lever up here, like that, that engages, that puts tension on that belt and tightens it, and then the blower actually starts blowing snow, right? The auger starts blowing snow. Okay, but this is that's the auger belt, right? And this is the drive belt. This is what powers the wheels. And so when I squeeze this handle, the drive wheel handle, I saw that move, and I thought that this moved here and actually engaged the belt. That's not the case, okay? So the case is this is obviously attached to this cable. We're going to run down here and run underneath it. Can you see that cable going all the way up there? And it goes to that plate. Now we're going to come around to the other side so you can see it from the other side. And here's the cable right here sticking down. And I'm going to squeeze the lever and just watch what that cable does. It pulls that plate backwards. Now that's actually pivoting on this post right here. Remember this post that we put the screw in right here, the nut, the bolt to hold it in place? It was flopping around before. Well, it's not flopping around anymore. And so what this is actually doing is when the engine's running, this shaft is turning right here all the time, right? It may or may not be driving this belt depending on if you have it engaged or not, but it's always driving this belt. And so this belt's always spinning. So this keeps constant tension on here. So be careful about over tightening this, because you don't want to over tighten this bolt here if you put this back on, so that this doesn't move. So when you tighten this down, make sure that this still moves some, so that the spring on the other side can actually keep tension on the belt right there, because all that is a belt tensioner. Back to the engine here. When the engine's running and this shaft is spinning, this belt is spinning all the time, right? And it's spinning this big pulley down here. So this big pulley is spinning right here, all right? This one right here. Okay, but what engages the drive mechanism is this little rubber-like wheel right here. It's got a, I don't know, it feels like plastic. I guess it's metal, but it like has a rubber compound on it right here, and it's actually engages from right here. As this spins, this comes in contact with this. So I'm going to squeeze the lever up here, the drive lever. Oh, it's a long reach. I'll try to hold this still so you can see what's happening there. And so that pulls the pulley back, and it engages that wheel, that rubber wheel. Okay. So hopefully that's coming out in the camera. We do it again just to make sure. So when this wheel's spinning, it's not driving the wheels until you squeeze the lever. That pushes this back against this wheel, starts spinning this, and watch what happens when we spin this. The wheels are turning, okay? So, okay, so that's an easy thing also. This doesn't engage very much. I mean, this is not pushing very hard. When we squeeze the lever, that pulls this back, and it's not pushing super hard against this. I don't know if it needs to or not, but that's something that you could adjust, or you could look at. Let's say you lose your drive. You know, you'd look at your belt and make sure this is spinning, make sure your belt's spinning, make sure this is good, make sure that bolt is there, right? And then, you know, just look inside there and see if it's making contact, because you can kind of see, if you look carefully, if that's making contact. We can kind of see from the top. I'm going to squeeze the lever again, and you can see it come back and hit that wheel. Right now it's not, and there it does. If you lose your drive, you know, it may just be that that's not making good contact there, and it looks like you could come up here and loosen this nut and then run this up on here to tighten it, if I'm not mistaken, or loosen it. Maybe you could play with this adjustment here. Okay, and then just make sure that, you know, all the pulleys are in place, that the cable's in place, that cable hasn't broken here, because that can happen as well. And if it pops off here, you know, you're not going to have drive. So there's several things that could go wrong. This could even come off right here. Maybe it could come off above there, you know. So just easy things to check if you lose drive. Now, of course, other things can cause drivability problems. But so when I turn the tire right here, look how that spins right there. Okay, so that'll kind of make sense, at least in an overall mechanical fashion. Also, we've got it standing up on its nose, and we can look at kind of what how the transmission works here, okay? So this is another thing that you can check if you lose drive. This is something else that you can look at. As far as the drive lever goes up here, there is, you know, 6 forward speeds, 1, 2, 3, 4, 5, 6, and then reverse 1 and reverse 2. Okay, so if we put it through the different gears, that makes it go faster, of course, in forward. That's the slowest. Reverse 1 is kind of pretty slow, and reverse 2 is a little bit faster. Okay, so let's just put it in 1 right now, and now let's go look underneath here and see what's happening. Now this, if the lever is just attached to this little support right here, and it has a little spring right here, and that spring, of course, when you push the lever over, it springs back because of this spring tension that's underneath this bolt right here. Now it just moves this little arm, which is attached to this shaft. So these are all things that can loosen up, and then you won't have drive, right? So, and these cool little R pins they're using are kind of like locking R pins. They're not just like regular R pins. So they kind of lock. It's kind of cool. So the shaft comes down here, and as you move the shift lever forward and back, that moves this up and down. And to not make it too complicated, we're going to look up underneath here though. And basically this shaft comes right through here and then moves this little arm. And this arm is attached to this right here, whatever this is. But most importantly, it's attached to this rubber wheel. Now this rubber wheel we looked at from the front, if you remember right, when we engage the drive, that pulls this flywheel backwards against this wheel right here, okay? So this engine, when it's spinning, this thing's spinning, but if it's not engaged to drive one way or the other, reverse or forward, it's not in contact with this, right? You squeeze the lever, this comes back, hits this, and then depending on where this is in relation to this that's spinning only one direction, it either spins this forward or backwards. And then how fast does it move? It depends on how close it is to the center or how far away it is from the center. Now, the wheel is spinning at the same rate on the inside and the outside, right? So it's not spinning faster RPMs on the inside than the outside. So, but what's happening is the further away from the center of what it's spinning, it's covering more area. So it's having to go a further distance. And so the further this is away from the center, the faster the transmission is going to go. Okay, so where we're in speed 1 right now, forward, right? Now I'm going to shift it into speed 2, and speed 3, and speed 4, 5, and 6. And see how it's getting further away from the center? So it's going to spin this faster. Now, if we go back to 1, that's forward 1 speed. So that's the slowest forward speed. We're going to go all the way to reverse now, and it kind of goes over to the center line, it looks like. And that's reverse 1. Then we're going to go to reverse 2, and that's reverse 2. Reverses are very slow. So I guess they don't want you to run yourself over. So we're going to go back to 1 now, which is just past, should be just past the center line. And there's speed 1. Okay, so this is pretty simple, right? As the flywheel's spinning this way, and it comes in contact with the rubber wheel on this side, the rubber wheel's on this side, the flywheel's going up, and when the rubber wheel hits it, it's going to push that side of the wheel up, which is going to spin the rubber wheel like this. This shaft has some teeth here that come in contact with this gear here, and so the wheels are driving forward, okay? And then, of course, when you shift it into reverse, this goes past the center over to here. Not very far though, right? But it's actually, the flywheel's coming down right here. So as it's coming down, it's hitting the front of this wheel right here, and it's actually turning the wheel this way, which backs the wheels up, which turns it into reverse. Okay, pretty simple, but some simple things that you can look at, you know, just look at it, see how it works, and take it apart. And then when you know, when you have a problem with it, you can at least check out the basic things, and a lot of things you can fix yourself. A lot of times it's not the engine, yes, necessarily, or the transmission that goes bad on these things, but something just comes out of adjustment, or like in my case, you lose a bolt, and then the whole belt comes off, as you saw, and yeah, here we are. So I made another video on this, and you can check it in my playlist, Powersmart Snowblower playlist on my channel if you want. But basically this bolt fell out right here, and that caused this rod to just flop around. And this rod goes, it's attached here with a bolt. On the other side, the rod's just tapered down and goes through a little hole on the other side. But basically this rod is attached to this big pulley. And this big pulley is what was flopping around, and so it wasn't driving well. The belt was about to shred because it was so out of alignment. But I Loctited this bolt in, that's probably enough. But we're going to do something fun. We're just going to cross drill the bolt right here and put a little piece of safety wire on it. We don't have to do this, but I just bought a bolt drilling jig, which I've wanted for the past 25 years or so. So here's the bolt drilling jig, and you can see you could put several sizes of bolts through here, and basically you just drop the bolt through there, and then you tighten this down on top of the bolt. Now, it came with 2 of these, and you'll see that it has a hole right there, and that's your pilot hole. That's a braided bolt right there. So, and there's an extra one here. But basically this 1/16 is what fits it, I think. Yep, 1/16. And you can buy these. These are cobalt twist drills, and I just got these off Amazon. There's 12 of them in there. They're small, so you have to be super careful. But basically those allow you to cross drill it perfectly straight across. You can see that it kind of rocked. Maybe you can't see it in the camera, but it basically, when you tighten this down, it kind of rocks the bolt over. So what you want to do is put a nut on the back side like that, and you don't have to tighten it tight, but that'll keep it from rocking over. And then just tighten it down against one of the flat edges, and then you can drill. Now, these are thin drill bits, right? So you can break them off really easily. It's much better to do this in a drill press and take your time. I should be using cutting fluid, but it's in store. Oh, I have some right here. Look at that. Cutting fluid. I didn't realize I had that. We're just going to put a drop on here. Hopefully just a drop. Maybe a whole quart if it starts coming out quick. Okay. And you want to drill for a few seconds and then pull your drill out while you're running it to clear your chips, because your chips can't clear easily because they're down inside this bolt. Okay, so here we go. And this is, this is something you take your time with. This isn't, don't try to drive it in fast. Heat's your enemy, right? We have a perfectly drilled hole right there. Looking at size of the safety wire, they'll go down this 1/16 hole. This is 1.57 millimeter. 1/16 is 1.57 millimeter. And this wire is 0.041, which is 1.04 millimeters, so it's a little bit smaller than 1.57, and it goes right down it. So that's a good size. This is thinner wire. It doesn't have to be super strong, but it's easier to work with than this thicker wire. This is kind of hard to tie and to manipulate where you want it just because it's so thick. This is 0.062. So that's a nice fit. Let's get it on. Now, typically what I do is cross drill 2 bolts next to each other so that you can run it through one, run the safety wire around this way and run it onto the other one, and then run the wire in a fashion so that the bolt, if one tries to loosen, it's like tightening the other one, okay? So you can watch videos on that. That's really cool stuff. But typically what I do is, unless I'm worried about 2 fasteners that are close together, I'll just run safety wire from one and then drill a little hole and put the safety wire in a hole. Okay, so in this case, I'm just going to use safety wire pliers, and you don't have to use these. Oftentimes I'll just grab my vice grips and use those because those work just as well. You clamp them on there, spin it up, and this just makes it a little bit faster. And you can pull this little thing back here and it spins the wire. But you can see even twisting it with even something like a vice grip, it works just fine. Okay, good. We'll try to get that a little bit snugger. Don't overdo it because even safety wire will break. Just drill a little 1/16 hole right here and we'll pass the wire through there. All right. Okay, now we're just going to bend this over just so that's not a sharp piece sticking up and it doesn't interfere with that spring. I'm going to bend it over this way. Maybe tuck it inside. There's nothing that it'll interfere with down there. Okay, that's done. Now I can hear what some of you guys are saying. Bro, why would you do that? It's taken so long. It takes forever. It does. But I just got this drill jig. I'm super excited about it, and I'm never gonna have to worry about this bolt again. Now, should you go over your bolts anyway on your machine, before you use it during the season, periodically during the season? Yeah, of course you should. But do we do that always, all the time? No. These motors, that are not, the major brands, they tend to run a little rougher sometimes. Some of them do. And, that vibration can make things loosen up. There's vibration in the drivetrain. There's vibration in the, there's vibration from different things here. And so any of these bolts can loosen up. So to go over it at least once a season, make sure, put a tweak on everything. Just make sure everything feels snug and tight. It's always a good idea. But I'm never going to have to mess with this bolt again, ever. And hopefully for the life of this snowblower. Okay, guys, we're just going to look inside of the gearbox here and see if there's if they've used oil in it or grease. It's typically is filled with grease. I'm just going to pull this plug here and pull this plug here just to make sure. We'll look inside. I'm going to order some grease just so we can fill this up and make sure there's plenty of grease inside. And we'll look at this. Well, this is dumb. Okay. See that? That's a third of the way out there. That one's okay. That one's okay. I'm going to put a wrench on all these. But look at that. That just loosened up from vibration or whatever, or maybe wasn't torqued right from the factory. I don't know if this is going to come out in the camera or not, but it looks like there's grease inside there. I'm not seeing bare metal. I'm seeing grease. So I'm still going to order some grease and put it in here, and just to make sure it has plenty. Okay, this may or may not be a thing, but when looking at that rubber friction wheel, when it engages with the big wheel for drive, maybe slipping it might not be a good idea because I've been kind of engaging it kind of slow, and it may be just better just to engage it quickly to get so it's not slipping and tearing the rubber up. I don't know if that'll shorten its life or not. You guys let me know in the comments what you think about that. Okay, so I'm not a mechanic, but obviously I don't mind fixing my own things if I can. I got that from my brother at a young age where he I didn't grow up with a dad. I didn't have a dad around, so I didn't have anybody to show me how to do stuff necessarily, or to, even a watch, working on a car or anything, because there wasn't a dad around. So fortunately, I did have my older brother, and he was about 10 years older than me, and he taught me two things. He knew he couldn't be around to teach me, this is how you tighten this, and this is how you fix this, and this is, but he taught me two basic principles, and that's benefited me my whole life. And so one of those principles was, if you think you can or you think you can't, you're right. And you probably heard that before. I think Henry Ford said that. My brother didn't coin that phrase, but he was right. And so I've tried to think like that and try to be positive about when I'm attacking something or doing something. And so if you watch my channel, you know that's very obvious. I'm not afraid of anything. So, but the other thing was, he said, Eric, if you pay attention to how you take something apart, you'll always be able to get it back together. So in other words, if you have something break and you pay careful attention to how it comes apart and be detailed about it, you'll be able to get it back together, and at least it'll be in the condition it was before. And it may be better if you're able to fix it. And that's kind of how I'm looking at this. I'm taking it apart, I'm looking at it, I'm trying to learn about it. Hopefully you guys are learning from this video too about how this thing works, and hopefully it'll help you if you ever have to fix your snowblower. There are some simple principles with this. Now that we understand these, hopefully we can fix these things and keep them going. Now this is a cheap one. This is not a $2,000 snowblower like I wanted, the one with the tracks, with the highest rating and the best engine that'll last 50 years and all that stuff. But I didn't buy that. I bought this $500 one. And so it might take a little maintenance or a little tweaking here and there, just like we found. But come along with me. Go ahead and subscribe if you're interested in this stuff. I'm going to be doing some other things to this snowblower to get it working and keep it working. I have had problems with it. I'm going to make a video on it, of course, to let you know. So if you have the same one or a similar one, let's talk. Let me know in the comments what's working for you, what's broken on yours. If you made videos on yours, please share them with me, because I love to see other people's videos. I don't watch TV. I spend all my time on YouTube watching what other people do to fix their stuff and to keep their own stuff going, because that's my life. I got to keep my stuff working. I can't pay somebody to fix all my stuff all the time. So, and this is one of those things. If I can fix it myself, I'm gonna. Okay, well, good. I hope this video helped you guys, and I'll see you in the next one.